astronomers have spotted a strange new feature on 3I Atlas, a narrow anti-tail stretching toward the sun instead of away from it. Observations from the Keck II telescope confirm this unusual structure, sparking debate among scientists. Some suggest it's just a viewing effect, while others believe it may be caused by dust dynamics or rotational ejection from the nucleus. Whatever the cause, this is one of the most intriguing interstellar observations in years. In this video, we'll explore the discovery, the leading scientific explanations, and its implications. Let's get started. 3I Atlas is the third confirmed interstellar object to pass through our solar system, after 1I/Oumuamua and 2I/Borisov. Discovered earlier this year, it's currently on a hyperbolic trajectory that will carry it back into interstellar space once it swings past the sun. In August, astronomers observed the object using the Keck II telescope in Hawaii, when it was about 2.5 astronomical units from the sun. Spectroscopic analysis revealed outgassing of cyanide and nickel consistent with cometary activity. But the imaging data showed something surprising: a thin tendril of material pointing directly toward the sun. This anti-tail is the opposite of what's typically seen. Most comets develop a bright tail pointing away from the sun, pushed by solar radiation and the solar wind. But in this case, the most prominent structure is oriented sunward, and no conventional broad tail was visible in white light. This makes 3I Atlas's appearance unlike most known comets. Anti-tails have been observed in some solar system comets before, but they are uncommon and usually faint. Seeing one on an interstellar object is particularly striking, since these bodies carry signatures from beyond our solar neighborhood. The detection suggests the dust and gas around this comet behave in ways we don't fully understand. The observations are currently published as a preprint and undergoing further analysis. Researchers confirmed that both cyanide and nickel emissions occur in multiple directions, supporting the physical reality of the structure rather than an observational artifact. This sets the stage for focused studies on what's causing the feature and what it reveals about the nature of this interstellar visitor. An anti-tail isn't just a visual oddity, it reflects the physical properties of the dust and gas surrounding the comet. For an interstellar object, those properties may differ significantly from what we observe in solar system comets. There are three primary scientific explanations under consideration. 1. Geometric perspective effect. In some cases, if Earth is positioned at a particular angle relative to the comet and the sun, the tail can appear to extend forward rather than backward. A broad fan of dust can, from this vantage point, look like a narrow sunward spike. This phenomenon has been documented before with solar system comets. 2. Large dust grains. Radiation pressure pushes small dust particles away from the sun, but larger grains are heavier and less responsive. These particles can remain near the orbital plane, or even appear to extend toward the sun when viewed from Earth. If 3I Atlas is releasing a significant number of large, slow-moving particles, it could produce a stable anti-tail. 3. Rotational ejection of material. If the nucleus is spinning rapidly, material ejected from sunlit areas can be flung both ahead of and behind the comet along its orbit. This would naturally align dust with the orbital path, creating a forward-pointing structure. Planetary astronomer Michael Bush explained that ejecta can end up in front of or behind the nucleus depending on its release velocity and angle. It's entirely possible that more than one mechanism is at work here. A combination of geometry, grain size, and nucleus rotation may explain why the anti-tail is so visible in this case. The chemical data adds another layer of interest. The outgassing of cyanide and nickel in multiple directions hints at active and possibly uneven sublimation. This reinforces the idea that the anti-tail is tied to how 3I Atlas is venting material as it nears the sun. What makes this significant is that 3I Atlas likely formed around another star. Studying its dust and gas behavior provides a unique chance to compare interstellar material with our local comets, something we've rarely had the opportunity to do. The anti-tail on 3I Atlas is more than a curiosity. It's a chance to refine models of cometary behavior and expand our understanding of interstellar objects. A. Refining physical models. Comet tails are shaped by a balance between dust emission, radiation pressure, and solar wind. Observing an interstellar object behaving differently challenges existing assumptions. If large dust grains are confirmed, it suggests differences in material composition and structure compared to comets formed in our solar system. B. Improving observation strategies. Because anti-tails depend heavily on geometry, they can easily be misinterpreted or missed. This event gives astronomers a reference point for what to look for in future encounters, especially with fast-moving interstellar visitors. C. Upcoming observational opportunities. 3I Atlas will make a close pass by Jupiter next month. Juno and JUICE, Jupiter Icy Moons Explorer, may be able to gather brief but valuable data on its activity. Even limited observations could help determine the structure and composition of the anti-tail more clearly. D. Implications for future missions. This encounter may also shape the way we approach future interstellar objects. Missions like Comet Interceptor are being designed with flexibility to intercept and study comets, including potential interstellar visitors. Understanding unusual features like anti-tails in advance can guide instrument design and observational priorities. Since interstellar objects pass through our system only once, each event is unique. Observations of 3I Atlas can set a baseline for how we interpret and prepare for the next encounter, whether it's similar or completely different. The sunward anti-tail on 3I Atlas offers a rare glimpse into interstellar material in action. Its unusual structure challenges existing comet models and opens new scientific questions. This brief encounter may shape how we study future visitors from beyond the solar system.